Chapter 2, Exploring Data with Tables and Graphs. Start with section 2.1, Frequency Distributions for Organizing and Summarizing Data. So kind of a consistent theme throughout this chapter is going to be these 5 terms: center, variation, distribution, outliers, and time. And so center is kind of like the middle of the data. And you've found measures for center before when you found mean, median, and mode. Those were measures of center. They're trying to explain or describe the center point or the center of the group of data. Variation, how much the data varies. If I asked everybody in here their age and then found the mean, I found the average. The average is probably going to be 17, 18, 17.5, something like that, without a whole lot of variation, because all of your ages are right there packed around 17 and 18. All right. But if I went to, like, let's say I went to your church and asked everybody sitting in the church, what's your age? And I calculated the average there's going to be a lot more variation because there's going to be some little kids there. There's going to be some old people there. I can find the average, but those numbers are going to vary a lot more than these. So that's variation. I think that's a hard concept, but it doesn't come up really today. Kind of a preview. Distribution is the nature or shape of the spread of data. You've maybe heard of a bell-shaped distribution. A bell-shaped distribution is one possibility, but we're talking about how the data looks, the shape of it. Outliers are far away from the others. Time is talking about some change in the data over time. So these are kind of key terms, the key things that will come up again and again. But center, variation, distribution, outliers, and time. Now, as far as this chapter, a key concept is going to be talking about frequency distribution. That's the name of the lesson. When working with large data sets, a frequency distribution or frequency table is often helpful in organizing and summarizing data. A frequency distribution helps us to understand the nature of the distribution of the data set. So you've seen something that looks like this in algebra class. It's called a dot plot, and it's pretty good to kind of visualize what the numbers are. I can look at this and see 5 dots on the number 40 here. So I know there must have been 5 instances of that number 40. But the problem with this is, what if I've got a lot of data points? It's going to be really hard to, first of all, draw this dot plot. And second of all, if there's enough data points, it's going to be really hard to get anything or make any sense out of this if there's enough points. And so that's where our frequency distribution is going to come in. Okay, frequency distribution right here shows how data are partitioned among several categories or classes by listing the categories along with the number, frequency, of data values in each of them. All right, so it's a little bit different. It's like taking this table and saying, okay, I'm going to kind of break this down, and instead of saying each of these numbers individually, I'm going to group these together and say between 10 and 50 there are, 5, 10, 15, 20, 25. Let's say there's 29. I'm not going to count them, but let's say there's 29 instances of numbers between 10 and 50. And then I might say between 51 and 100, there would be, I don't know, whatever that is. Let's say it counts up to 42. And so we're just kind of trying to simplify the data and organize it in a little bit easier way to understand. So we're talking about the categories or classes would be these 5 things. Those are the 5 categories or classes. And when you look at this table, they're saying here are a bunch of times in between 75 and 124. Well, how many specific times are there between 75 and 124? 11. That's what this is. That's a frequency distribution. That's the name of the lesson. You'd think that's an important concept. Here are some important definitions. Instead of having you write them all down, here they are. All right. Lower class limits, the smallest numbers that can belong to each of the different classes. So let's look at this frequency distribution above. The lower class limits, or the smallest number for each class, would be like 75, 125, 175, 225, and 275. Those are the lower class limits for that table above. The upper class limits are just the largest numbers for each class. So we would see 124, 174, 224, 274, and 324. Class boundaries is a little bit weird, but it says the numbers used to separate the classes, but without the gaps created by the class limits. I think that's really hard to understand, but basically they're talking about in between the classes. So if, look at the first class and see how its highest number is 124, but then you go to the next class and that's 125. You want to find the number that's in between those two numbers. So it's a matter of averaging the two numbers, but finding the middle of those two numbers is just going to be 124.5. It's kind of weird, but 124.5. Leave some room in front of that, to the left of that, because there's actually one before that, but it's kind of hard to find it until you've found the others. So I'm looking at the numbers in between. And so in between 174 and 175 is 174.5. And then in between the next ones is 224.5. And in between the next ones is 274.5. And so all that's great, but you actually need to find two more. There's going to be one at the beginning before the first number. And so really all you have to do is kind of identify the pattern. It's going to be 0.5 away from that first number. And so since, you go in between and it's always 124.5, it's halfway in between. So use that pattern of, well, it's 0.5 before the lower bound. And so this is going to be 74.5. And so then at the end, there'd be another one. But again, in this example, it's just 0.5 away. So that's going to be 324.5. And I'm kind of out of room. 324.5 right there. Those are the class boundaries. The numbers used to separate the classes, but without the gaps. Class midpoints. Class midpoints, I think this makes a little bit more sense. The values in the middle of the class, in the middle of each class. So just this time, we want to find right in the middle. And so you can just find that by averaging those two numbers. 75 plus 124 divided by 2. 99.5 is right in the middle. And so that's that first class midpoint, 99.5. So we want to do that for all of them. Right in the middle of this is going to be 149.5. 149.5. At some point, you're going to notice a pattern, so you don't really have to do the math. This one is going to be 199.5. If you don't see where I'm getting those numbers, then feel free to find that average on a calculator. This one, anybody know what the middle here is going to be? The middle's about 250, right? But looking at the pattern, it's not going to be 250. It's going to be 249.5. And then there's one more, the middle of this. Anybody know what that's going to be? 299.5. That's right. 299.5. Class width says the difference between two consecutive lower class limits in a frequency distribution. So the difference between two lower class limits, two consecutive lower class limits. So basically all we have to do is say, here's two lowers in a row. The difference between those two, 125 minus 75 is 50. 125 minus 75 equals 50. The difference between two consecutive lower class limits. All right, so those are kind of the things that we would need to find, I guess: lower class limits, upper class limits, class boundaries, class midpoints, class width. This is how you would do that. Here's the procedure, or how to construct a frequency distribution. Okay, that's okay. Number one, select the number of classes, usually between 5 and 20. So they don't really tell you what you have to pick, you just have to pick. I like round numbers. I like 5, I like 10, whatever. Notice in the example above, how many classes did they pick here? 1, 2, 3, 4, 5. There are 5 rows in that table. There are 5 classes in that example. So it says, pick how many classes you want. Do you want 5 groups? Do you want 10 groups? Do you want 20 groups? Probably good to have some kind of a nice even number. I probably wouldn't pick 13 or 7 or something weird. I'd pick something nice. Calculate the class width. So the class width is going to be calculated like this. We want the maximum value by the way, this is the maximum value when you're looking at the data points. What we're trying to do when we construct a frequency distribution is we'll be looking at a whole bunch of data points, a whole bunch of numbers, all right? And we want to make that table. We want to kind of summarize these numbers into a nice little table that's easy to look at, right? It's not very easy to look at all of these numbers. So that's why we're going to want to do this. So we want to take the maximum value of all those numbers that we see, and we're going to subtract the minimum value of all of those numbers that we see. Can't spell. And we're going to divide that by the number of classes. I think that's hard to understand what that means, but you'll see once we do an example, okay? Max value minus min value over number of classes. Now, there's going to be a question on your homework later that says something about how to find the class width. And this is a little bit tricky because up here above, I also showed you how to find the class width, all right? So there's 2 different ways we're talking about finding the class width, and it kind of depends on what you're looking at. If you're looking at a whole bunch of data points or a whole bunch of values, you'd use the formula that I just gave you. But if you're looking at the table, then you would just subtract 125 minus 75. So how to find the class width kind of depends on what you're looking at. So be careful on that question, I think. Notice it says we're going to round to get a convenient number. It's best to round up. We like numbers like 50 or numbers like 10 or numbers like 100, or, something that's good and easy to work with. We don't really like numbers like 43 or something. Okay. Number 3, choose the value for the first lower class limit by using either the minimum value or a convenient value below the minimum. For using the first lower class limit and a class width, list the other lower class limits. 5, list lower class limits in a vertical column, and then determine and enter the upper class limits. 6, take each individual data value and put a tally mark in the appropriate class. Add the tally marks to get the frequency. None of that means anything if you're not doing an example. All right, it's really, really hard to understand all of those steps. So I think the best way to understand it is let's just do an example. So what we want to do, we're constructing a frequency distribution, right? That's the steps for how to do it. And that's what example 1 is about. Construct a frequency distribution for the data in the table. This tells me to use 5 classes, all right? So what we've got is McDonald's lunch service times, and they're in seconds. So this first number is like 107 seconds. It took 107 seconds for them to actually serve your food once you ordered it. That's what they're talking about. So we've got a whole bunch of these numbers, drive-through service times, and we want to construct a frequency distribution. So you might have to flip back and forth to the steps. Step 1. Go back and look at that step 1 in the instructions, right? Select the number of classes, usually in between 5 and 20. Well, they already told me to use 5 classes. So I want the number of classes to be 5. That is the number of rows in my table. I want 5 rows in my table. That's what I'm going to do. So then step 2 says something about find the class width, right? Calculate the class width. And so we're going to use this formula, maximum value minus minimum value divided by the number of classes, which is 5 here. So you got to go through all these numbers and try to find the biggest number and the smallest number. All right. So we're looking, and I go through, and 308's pretty big. 206, no, 308, 308. I think the max value is 308. You can circle that or put some kind of mark by it if you want to. It doesn't really matter, but that's the maximum value. Smallest number, you got to be careful because one will jump out at you like this 91, but maybe there's something smaller. I see a 90. Okay, I see an 83. Anything smaller than 83? Pretty sure that's it. I've got the maximum value of 308 and the minimum value of 83. So I'm going to go 308 minus 83 divided by the number of classes. That's 5. So 308 minus 83 divided by 5 gives me 45. Okay, so this number, whatever this number means, the class width is 45. And that's not a bad number, but it says round up. It says round up to something nice, something convenient. It might be nicer to use 50. So I'm just gonna round up to 50 to make my numbers easier to deal with. It's gonna be easier to deal with a 50 than with a 45. So my class width, I'm setting at 50. It could vary. You could use 45. Somebody else might use 40, but the direction said usually you want to round up. Step 3. What was number 3? Choose the value for the first lower class limit by using either the minimum value or a convenient value below the minimum. So the minimum value was at 83. That's kind of a weird number. I don't want to use 83. I'm going to use something smaller than that. So a convenient number. I'm going to use 80. But 75 is good, 50 is good. There are some numbers that are just easy to look at. And so a convenient number just means something nice, something that's going to be easier to work with. All right, I'm going to choose 80 as my starting point. That's my minimum, that's my low number. 4, using the first lower class limit. That's what I just found in 3, right? That was my first lower class limit. And the class width, list the other lower class limits. Okay. So there was 80. And then since I'm setting the class width at 50, the next lower limit will be 80 plus 50 is 130. And then another one, plus 50 is 180. Plus 50 is 230. Plus 50 is 280. Those are my lower class limits. So step 5, list the lower class limits in a vertical column and then determine the upper class limits. So maybe it would have been better had I made it as a table. So we would have 80, 130, 180, 230, and 280. Those are the lower class limits, but they want me to find the upper class limits. So essentially all you're doing is you're taking the numbers between 80 and 129. The upper limit is going to be that 129 because the next level, the next class, the next row in my table is 130. So we're going from 130 to, it looks like 179. And then the next row is going to be 180 to 229. And then we have 230 to 279. And then the last one, I guess the last one you have to think a little bit. Basically, we're adding 50, right? No, not 50 quite, but 49. So the next one, 280 plus 50 would be 330. This is 329. 329. Questions on that? All right, so you can kind of see, the table starting to take shape. Six says take each individual data value and put a tally mark. So we're just going to tally all of these data points. So 107 is here. 139 is here. You guys see what I'm doing? 197 is here. 209 here. 281 bottom. 254. You're probably better off to do this yourself than copy me. Okay. But if you see me make a mistake, then give me a shout. 163 is here. 150. 127. 308. 206. You guys get the feel for what I'm doing? So I'm going to fast forward here. I ended up with 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 5, 10, 15, 22. The next level I had 5, 10, and then 3, and then 2. So those are my tallies. Those are my tally marks. And you could kind of check, I guess, by counting. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times 3 is 51, minus 1 is 50. There should be 50 numbers there. That should add up to 50. But step 6 says add the tally marks to get the frequency. So instead of tallies, you're not going to have tallies. You're going to have, that's 13. So your table is going to look like time and frequency. And you're going to have 80 to 129 has a tally of 13. And 130 to 179 is going to have a tally of 22. And 180 to 229 had a tally of 10. 230 to 279 had a tally of 3. 280 to 329 at a tally of 2. So there's our frequency distribution. We're just trying to summarize those data and make it a little bit easier to look at. Okay. Relative frequency is basically the same thing, except instead of having tally numbers, it's going to be a percentage. So in that table, you're going to end up taking the frequency divided by the sum times 100. So in our table, we had time and then relative frequency. When they say relative frequency, they're talking about a percentage. So if you look back at that table there, the first row is going to have, the first class is going to have 13 entries. So it's 13 out of the 50 total values times 100 is going to be 26%. 26%. And so then we've got 22 out of 50 times 100 is 44%. The next number was 10, so 10 out of 50 is times 100 is 20%. 3 out of 50, you might be able to do that in your head, times 100 is 6%. And the last one, 2 out of 50, that's going to be 4%, right? What do those percents add up to? They better add up to 100 or really, really, really close. They might be off because of rounding, but you got to be really, really, really close. It's not going to be 112%. It's not going to be 84% or even 97%. It needs to be 99.994 or something really, really super close. And it's only off because of rounding if it's off. Now, and that's what it says right there. The sum of the percentage in this distribution must be very close to 100 with a little wiggle room for rounding errors. Cumulative frequency distribution. I think this one's a little bit weird to look at, but cumulative is it keeps going. It's adding up, adding up, adding up, adding up. All right. So cumulative frequency distribution says the frequency for each class is the sum of the frequencies for that class and all previous classes. Now, this example is the one that they gave you. And if you go back and look at the one that they gave, the example that they did, it was a little bit different than the one that I gave you because they chose different values. Like I chose 80 and it looked like they chose 75 for their first one. So it's just slightly different, but it's the same data. It's the same stuff. So they used this one, 11, 24, 10, 3, and 2. That's what they used. So keep that in mind. So their first entry was 11, right? Their first entry was 11, and their second entry was 24, and then they had a 10 and a 3 and a 2. Well, this is cumulative. And so cumulative means you just add up. So in the first row, it's just 11, but in the second row, it's 11 plus 24. That's 35. And then the third row is 11 plus 24 plus 10. And that's 45. It's cumulative. It just keeps adding, adding, adding. So the next one, you add 3 more, you get 48. And the next one, you add 2 more, you get 50. And so by the time you get to the end, you've got that total number. Honestly, this is my least favorite of the 3 that we've seen. We've seen a frequency and a relative frequency and a cumulative frequency. I think this one's a little bit harder to read, but that's what it is. Cumulative. It all adds up. Okay. Using frequency distributions to understand data. They don't spend a whole lot of time talking about a normal distribution in this section, but it'll come up later. We'll spend more time on it later, but for now it will come up. It will be in your homework. Normal distribution says the frequencies start low, then increase to 1 or 2 high frequencies, and then decrease to low. So it kind of looks like this, right? And it says the distribution is approximately symmetric. So it's approximately symmetric. This is a perfect one. This one's perfect. It doesn't have to be perfect. It needs to be approximate. And so if you look at the numbers in this frequency distribution, you should see kind of the same thing. You see how it starts low and goes high and then comes back low. But you see how it's also symmetrical? From 2 to 8 to 30, back to 8, back to 2. Imagine if you graphed that, okay? If you graphed that, you're going from 2 to 8 to 30, back to 8, back to 2. It's kind of looking like this graph right there, all right? So when they talk about a normal distribution, you have to have these 2 things in place. Gaps. The presence of gaps can show that the data are from 2 or more different populations. The converse is not true because data from different populations do not necessarily result in gaps. Last digits. Frequencies of last digits may reveal how data were collected. So part 2, examine each table. Does either frequency distribution appear to have a normal distribution? How might one explain the gap in the weight and the frequency of the last digits? Okay. So you look at these numbers, this doesn't appear to go from low to high back to low. It doesn't appear to be symmetrical. That's not normal. This is not a normal distribution. And neither is this one, right? This one doesn't do that either. So neither one of them, I would say, are normal. How might one explain the gap in the weight and the frequency of the last digits? All right, well, I didn't give you a lot of context for this problem, but what this problem is talking about is the weight of a penny. And you can see that there's a whole bunch of pennies that weigh between 2.4 and 2.6 ounces right here, and then there's none, and then there's a whole bunch more pennies that weigh between 2.9 and 3.2. And so there's this gap. And they're saying, you know, how might you explain this gap? Now, I didn't know a whole lot about pennies. I didn't know this about pennies, but prior to 1982, pennies were almost all made out of copper. And like most of them, it kind of varied a little bit, but it was pretty much between 88% and 100% copper. So if you have a 1981 penny, that's mostly copper. But in 1982, they changed it. And now it's only 2.5% copper. And the other 97.5 is zinc. So it's completely made out of different materials. So perhaps the heavier pennies are more copper. I think copper probably weighs more than zinc. All right, but it's kind of implying that the two different sets of pennies are two different kinds of pennies. All right, less copper. It seems like they're talking about two different compositions of penny. Now the next one, I didn't give you any context at all. It's the last digit, but actually they're talking about measuring blood pressure. And when you measure blood pressure, you have to like take the pulse and count the pulse, how many times it beats per minute. But when you go to the doctor, normally they don't hold it on you for a minute. Normally they like hold it on you for like 10 seconds and multiply by 6. Or maybe they do 30 seconds and multiply by 2. And that appears to be what they've done here. Notice how we don't have any odd numbers. All these zeros are on the odd numbers of the last digit. So whatever the pulse rate was, they probably just multiplied by 2. They took 30 seconds. They took your pulse for 30 seconds and then multiplied by 2. All right, last one. This table shows the relative frequency distributions for drive-through at McDonald's and Dunkin'. What could account for the differences? Well, this is easy. All right, this is saying Dunkin' Donuts times are smaller than McDonald's. Why do you think that is? It's probably easier. It's probably easier to just hand you a donut than to actually fry up some food or whatever. So that's probably what I'm saying. All right, guys, that's it.